In this video, we will review questions from quiz 3. The review will have two parts. The first part over sections 7.3, 7.4, and 7.6, and then we will talk in the second part about constructing confidence intervals. So let's get started. A sample of size 50 will be drawn from a population with mean 10 and standard deviation 8. Use the TI-84 plus calculator to find the probability that the sample mean will be between 8 and 11. Round the answer to at least 4 decimal places. So first of all, I always recommend that students write the data and keep information. So the sample size, traditionally we use a variable n, it's 50. The population mean, so find the probability that x bar will be between 8 and 11. So first of all, since the sample size is large, greater than 30, we can apply the central limit theorem, and the central limit theorem tells us if the sample is greater than 30, then the sampling distribution for x bar will have a shape of a normal curve with mu x bar equals to 10 and sigma x bar equals to sigma over square root of n. So we will enter this in our calculator. So to answer the question A, find the probability that it's between 8 and 11, we will use the command normal CDF on TI-84. You go second bars and choose normal CDF number 2. So the question asks us about x bar to be between 8 and 11. 8 for lower and 11 for upper. Mu x bar is 10, as we wrote here, and sigma x bar is sigma over square root of n. So 8 divided second square root of 50. Close parentheses and paste. And we have the answer 0.7731. So we enter that answer, 0.7731. Always pay attention, round the answer to at least 4 decimal places. At least means minimum. You could round to 5 decimal places. We round to 0.7731. So the probability that x will be between 8 and 11 is, and here we put 0.7731. Find the 10th percentile. Since our distribution is normal, we can find the 10th percentile of x bar. For that, we are looking for the z-score, which separates lower 10%, so it's 0.1 here area, from the upper 90%. To find the 10th percentile, we will use the command in the norm. In the norm and enter. Then you need to enter the area to the left, 0.1. So mu is 10, and sigma again we need to enter as a quotient 8 divided by square root of 50. Let's calculate this, and we need to read how many decimal places, at least 2, so it will be 8.55. So 8.55 is the 10th percentile. So if we had x bar equals 8.55, it would separate lower 10% from upper 90%. Next question. Watch your cholesterol. The mean serum cholesterol level of US adults was 203. So we're going to start here writing the data and put this all information for us conveniently at one place. The mean serum cholesterol for US adults, so this is the population because it's for US adults, mu equals 203. With the standard deviation sigma of 42. A simple random sample n equals 109 adults. Use GI84 to answer the questions. What is the probability that the sample mean cholesterol level is greater than 213? So since sample size is large, greater than 30, we can apply again normal CDF command, greater. So we're going to use normal CDF, and normal CDF second bars, option 2. So what is the probability? The sample mean is greater than 213. So the lower 213, and for upper we use 1 second comma. It's for E 99. It represents a very large number, 10 to degree 99. So it's a large number. We don't have a symbol of infinity on this calculator. That's kind of we use 2 or 3 for mu, and sigma x bar is 42 divided by square root of 109. And we got 0.065. Usually when we're talking about probability, we need to round to 4 decimal places. So the answer to this question will be 0.0065. So the probability that the sample mean cholesterol level is greater than 213 is 0.0065. What is the probability that the sample mean cholesterol is between 191 and 201? So we're going back to normal CDF, and now we need just change their lower and upper. So between 191, so 191 and 201. Everything else remains the same. So it's pretty quick, and the probability will be 0.3081. So the probability that the sample mean cholesterol is between 191 and 201 is 0.3081. Would it be unusual for the sample mean to be less than 191? So the unusual event is the event with probability less than 0.05. So first we need to calculate the probability of the event that the sample mean less than 191. We're going to normal CDF again, and in this case we need to, since it's lower on the left hand side, you will have negative infinity, which you put negative 1. And I bring attention that it's not negative sign here, which is subtraction, it's negation sign. 1 comma for E 199. This is a very small number. To the left side of the x-axis, we enter 191 here and calculate. So the probability is 0.0014, which is much less than 0.05, and for that reason we say it would be unusual for the sample mean to be less than 195, since the probability is 0.0014 less than 0.05.